All right, well, here we go. Chapter 3.3. We're going to talk about, again, the rectangular coordinate system. We're going to talk about slope definition. We're going to talk about all three of these bullet points, but today, 3.3a, we're going to talk about the slope and kind of definition of what the slope is. So, you'll notice if you printed out the handouts that there are some pictures here at the very beginning. Uh, you're talking about slope, so we'll kind of tell you a story about a slope because college professors sometimes you think, oh boy, these guys are just, ivory tower people. They don't lead any kind of lives. Well, back when I was about your age, my buddy and I went out. We went skiing to Colorado, and we went to the top of. If you look at a mountain, you can look at sometimes a bare part of a mountain. And if you're looking up from the bottom of the slope to the very top, you'll look at some if there's no snow on the slope, you would say that it would be kind of a rocky face. But when the snow comes, the rocky face is covered uh, by a lot of snow, and they call those bowls. And the bowls look essentially like a bowl of, well, a bowl that you'd eat out of. And if you get to the top of one of the bowls, in fact, my buddy and I did, you have to ride a ski slope or a ski lift like this. Um, from the bottom, and you go from the bottom, up one ski lift to the other one. You got to go another ski lift. You get another ski lift, and essentially you got to go a couple of different three ski lifts, and then make your way over to a point right over here. And my buddy and I did this. We got to the edge of the bowl, and he and I are both 25 or so. And we both looked at each other and said, do we really want to do this? Because we get to the edge of the bowl, and essentially our skis are pretty much out over the edge of this cliff. So we're looking down saying, oh my gosh, we're going to really do this? Do you really want to do this? And sure enough, we did it. He went first, and he went ski, ski, ski. He turned a couple times, and I think he tumbled and kind of got to the bottom of the slope, kind of on his back, but he made it down. I said, oh my gosh, I guess he went first, so I have to go as well. So I went down, and I skied. I turned a couple times, turn, 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 and I actually made it down to the very bottom of the slope on my skis. And I got to the bottom, and if you know anything about skiing in powder is different from skiing in packed powder. So on the slope itself was packed powder, and you're supposed to ski to the very front of your skis when you're going on packed powder. But when you're on loose powder, you're supposed to kind of fall back on your heels so your tips of your skis don't fall into the snow. Well, sure enough, I was blinded by all this snow up here because it is pretty bright up there. And I didn't notice that everybody was going to go into the left so you can kind of follow the trail. And I went pretty much straight down where my buddy had kind of just fallen down. And sure enough, where he was at was loose powder. And I was skiing on packed powder. I was in the form of packed powder skiing. And sure enough, my tips went down, and I did a face plant at the very bottom. But you know what? I made it all the way to the bottom, and when I got to the bottom, I did a face plant. But this is about what it would be like. In fact, when I was up there, I think it was a lot steeper than what that was, because I think that just doesn't reflect the steepness of the bowl that I went down. So sure enough, there's packed powder. This is actually loose powder. This guy's skiing through a lot of loose powder, so he's kind of got his, he's back on his heels, and he's kind of letting the ski kind of shoot up outside of his skis. So that could be an approximation of a guy who looks like me who's going down a slope. But the reason I'm telling you the story is because we're talking about slopes, and sure enough, we can talk about slopes by saying, well, if we're going down a slope that's kind of like this is a little bit different from a slope that might be going down like this, and it's different from a slope that might be kind of going like this, which is kind of maybe the bunny hill if you're going down a slope. So we're going to talk about slope kind of as a rate of change of going down a ski slope, and we're going to use that analogy of going down the ski slope to kind of talk about things. So remember, if we're talking about slope, we're talking about rise over run. We're talking about how steep it is, how much drop you have on the ski slope, and also how much how much that, or I guess how that translates into um, our x's and y values. Slope is kind of defined as rise over run. In other words, how much, if you've got a line over here, how much rise there is for every unit of run. How much rise there is for every unit of run. It's going to be the same. That slope is going to be the same wherever you measure it on that line. Even if you measured it from even here to over here, you'd have the same rise over run ratio. If we're talking about x and y axes, then it's the change, and I can use this term, change in y, or divided by change in x. So that little triangle sign is, you'll probably see that later on in physics and chemistry. Its change means, or that delta is actually, that triangle is short for d or delta, which is in Greek the delta, but it means also difference. So this triangle means change in y, and this is change in x. So we're going to talk about change in y over change in x. So if we're talking about something like this, we can also talk about, kind of ideas about real life. In construction, we're going to use the idea of slope for roof pitch and maybe even stair ramps. If we're talking about wheelchair accessible ramps, the ramp has to be a slope of 1 to 12. So the rise here can be 1, the run has to be 12. So this would be a slope of about a wheelchair ramp access, 1 to 12 access. So that's what ramp steepness is. You can talk about roof steepness as well, and talk about the slope and how it kind of relates to slope. Which roof is steeper, 612, 812, or 1012? Well, roofers always want to talk about 6s and 12s, and especially 12s, because that's a foot. So which roof is steeper? Well, if we've got a 612, it would be something like about this. You get 12 for your run and about 6 for your rise. So here's a 6, 12. Now if we're talking about, there's your 612. If we're talking about 812, we'd have 8 for a rise. So extend that a little bit. We'd have our same 12 run, and we'd have now 8 rise, and that's a little bit steeper. So if we go even to 1012, we can go to the 1012 and say, well, we're going to go even a little bit higher. And from that same 12, here's our 12 run, and here's our now 10 rise. That would be even a little steeper. So 1012 and 812 and 612 are all roof pitches or roof steepness. And if you're talking about, if you're talking to OSHA, Occupational and Safety Health Administration, something like that, they would tell you that for a 612 pitch, something like that, a little, kind of a moderate pitch, you probably don't need protective gear. But when you get to maybe an 812 or maybe a 1012, that looks pretty darn steep. And to be honest with you, I've worked on roofs that were kind of a 1012 as well as a 612 pitch. And when you're on the 1012 pitch, you're going to definitely want something, you're going to want OSHA out there kind of protecting you. So this is kind of the real life application of what that steepness and the pitch and the slope really talk about. So let's talk about quantifying slope and really kind of what we are doing in this exercise, I guess, is kind of quantifying slope. We talked about what it is, and now let's quantify it. Essentially, we can quantify slope because we always want to quantify it because we're mathematicians. We want to get a number for it by using any two ordered pairs, or really any 2 points from that line. So those two ordered pairs can be any value for x, whatever number we find on our line, we can call x1, y1, and x2, y2. And the reason we do that is so that we can quantify it. Again, we're going to say that it's the change in x over the change in y, or sorry, the change in y over the change in x. So here's our slope formula. Slope of a line passing through distinct points is m, number one, it's going to be m equals. So slope is always going to be m. And here is our slope formula. y2 minus y1 over x2 minus x1. That's something you're going to have to memorize. You're always going to have to just know that slope m equals y2 minus y1 over x2 minus x1. And that's why, for this reason, this is our slope definition. This is the reason that we've kind of created x1 and y1 and x2 and y2 and called them by that name, so we can use those x1, y1, x2, y2 values over here in our definition for slope. So here, right there, is something that you got to know. You got to memorize. You got to take it home. You got to put it on a flashcard so you can memorize it and say, what's my slope? Slope m. Always say that slope. Slope m is y2 minus y1 over x2 minus x1. provided that x2 minus x1 is not equal to 0, because if it was, this number would be 0, and we're dividing by 0, and we can't do that. We're going to take a look at this in just probably a couple videos, I suppose. But this is our definition right here, and that's going to be the important thing for today. Slope m equals y2 minus y1 over x2 minus x1. Write it down, memorize it. We're going to use it in just a second. So there's our definition.